Y'all, coming back at you from La Casa de Mackenzie, up in the guest room slash office. Hope things have been going well. We're about to go over day 9 of our continuation of a learning plan here for algebra. It really hit me this week. This is one of my favorite things to teach every year. And, just the challenges of doing it virtually are a little daunting, but I know I love this and I know you can do it. And I'm really excited to show you some stuff with this factoring. What's really cool, I put it as a little thing on the title page when we get to the example problems and slides, is you're going to be solving quadratics today pretty much without even knowing you're solving quadratics. And I think that's pretty cool. So we're going to take a second degree trinomial, which is going to be have a first term with leading coefficient of 1. So it's kind of a special case quadratic. And we're going to turn that trinomial into two binomials. And we're going to do this using prior knowledge. So again, this is kind of going to be one of those things where it's nothing new. It's just a new way that we're going to put things together. So just continue to let you guys know I miss you. This week, office hours are going to be Wednesday at 3:30. I already put the link to the Zoom meeting on Classroom for you. I think there's some opportunities there to click it and have it automatically add to your calendar maybe. But I hope to see some of you there. I got to answer some math questions last week, and that was really refreshing. And just know I continue to work hard for you. Hit me with those emails. Another reminder: if you do something after I've graded it, you need to email me. It's impossible to go check the way that things are recorded. Each little individual person's each little individual thing. But if I know to go looking for it, not that hard. So keep those coming. Let's get after it here. So we're going to take a trinomial, and we're going to factor into two binomials. And so this is going to be useful. Like I said, you don't know it yet, but when you're going to be solving quadratics, this is a really good skill instead of using a quadratic equation. So here's that trinomial I'm talking about. Now these trinomials can have other numbers right here. We're going to be using leading coefficient 1. And so really the goal is to take this 3 terms, and we want to get it into two binomials. And this gets a little tricky. It takes a little extra thinking. So I kind of like to break it down. I think about this first term first. And if you think back to our distribution stuff, when we had like two binomials, let's just call this x, y, z, and a, we would distribute the x to those two terms, and we would also then distribute the y to those two terms. So it's the same kind of idea. So when I distribute my term here, my first term there, the only way I can get a p squared is a p times p. So I know the first term of my binomials has to be p, because the only way to get p squared is p times p. Okay, next I'm going to focus on the third term, 12. And here are the different ways. Now I don't do this every time. I can kind of look at this and just get answers, but this might be a strategy you want to use. I know I can get to 12 with factors of 1, 12, 2, 6, and 3, 4. And these are all going to be a whole number. They're going to work out nice. So that's going to be whenever I multiply this term by this term gives me that. But you might be thinking, well, what about that middle term? That's 7p right there. Well, we get that 7p by when we do that multiplication and that multiplication, we're going to get something p for both. And we're going to add those like terms. So what I'm going to do is I'm going to look at these groupings of 2 and see if I combine those like terms, which one would give me 7. Right there we got winner, winner, chicken dinner, 4 and 3. So let me show you why it works. And I know this is new. There's a lot going on here. So I got my p squared right here, p times p. Here's where my 7p comes from. When I distribute this p here, I get 3p. When I distribute that 4 there, I get 4p. So let's pretend like we're doing distributing. We got p squared plus 3p. I distribute my 4, I get 4p. I distribute my 4 to the 3, and I get 12. So there is my p squared, my 7p, and my 12. So my answer, I know there's a lot going on here, would be that p plus 4 and p plus 3. And it's like pretty much solved for a quadratic. We don't need to worry about that right now, but just so you know. So again, let's focus on this first term, n squared. I know I'm going to get this into two binomials. So I have to have n times n to get my n squared. Next, I'm going to look at my third term, negative 36. Or let's just think 36. So I got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. But here's the deal. In order to multiply and get a negative, so I'm multiplying these two terms here. To get a negative, I would have to have one positive, one negative. And here's what that tells me. When I am setting up my binomials, I need to have one positive, one negative binomial. Otherwise, there's no way to get that third term to be negative. So I know that the difference of something here is kind of going to get me there. You know what I mean? So, what multiplies to be negative 36 but adds to be negative 5? So I'm hoping your eyes come right to that 9 and that 4 right there. So, because the difference of 4 and 9 is 5. Now here's the little bit of challenge. You have to decide which one's positive or negative. Well, since my negative 5n is negative, the larger one has to be negative. Now you could write that as n minus 9 and n plus 4. It's the same thing. All right? There's a lot. I did 10 examples this time because I know there's a lot. It's going to be one of those things, and it's one of my favorite things to see every year. Your eyes are just going to light up when you get it. It's just going to take a little practice. But really, we're not using any new principles of algebra. And what's cool is you can always check your answers. So like if you took your binomial here and you distribute n, you get n squared and negative 9n. You distribute your 4, you get 4n and negative 36. Right there's your negative 5n. Right there's your negative 36. And right there's your n squared. So you can always check it by doing the previous lesson where we multiplied two binomials. All right, here we go. This one's a little nicer because it's all plus. So if it's all positive, I know I've got two positive binomials. My b squared by that b times b, that's already handled. So I'm looking at my third term, 42. And let's do one more where we list all the factors. 2, 21, 3 and 14, 4, 5, 6 and 7. Is that all of them? Yep. Okay. So I know because this times this equals 42, but I have my b times that unknown and this b times that unknown. A sum has to equal 13b. So I'm looking at that pair right there, 6 and 7 is 13. That has to be my binomial. So I'm going to check it. b times b is b squared. b times 7 is 7b. 6 times b is 6b. 6 times 7 is 42. There's my b squared. There's my 13b. There's my 42. And guys, don't be afraid to rewind, slow down, do it again. Don't be afraid to go look at another video on YouTube. Maybe someone else is vibing for you. That's cool. This is a pretty common algebra standard, so there's lots of opportunities. All right. So we got r, because of r squared. Okay, cool. I got 24, so my factors, let's just keep listing them. I guess I'm vibing with that today. You'll get some practice in, and you'll just be able to list them. Okay. Now, the only way to get a third term to be negative when I multiply is to have a positive and a negative. Right? Because this times this is going to give me the term without a variable, and it has to be negative. So now I got my negative 24. I need it to add to be positive 2r. So I know that my larger number has to be the positive, and it needs to get to be 2, the difference. So right there, 6 and 4. Positive 6, negative 4. So that's my answer. Let's check it with our distribution. This probably be the last one we check. We got r squared minus 4r, and I got a 6r minus 24. So here's my r squared. Here's my 2r. Here's my negative 24. We did it. Let's keep them going, guys. I am lined up 10 for us today. I know it's one of those things. If it hasn't popped yet, just keep at it. It's going to pop. So I know I've got x squared. Now this one's interesting. It has to multiply to be positive, but add to be negative. The only way we can do that is by having my binomials both be negative. A negative times a negative is going to give me the positive, but add to be a negative. My factors of 30, 130, 215, I'm going to stop right there. No, I'm not. Let's see, 310, 5, and 6. All right, so they add together to be 13. That's right there. I need a -3 and a -10. So let's just check it by multiplying. X squared minus 10x minus 3x plus 30. There's my -13x. Money. Let's keep it rolling, friends. This one multiplies to be negative, and that means I need one positive, one negative. Otherwise, that wouldn't make negative. My factors are 148, 224, 316, 412, 6, 8. Now, if you can just see this and see how the factors are going to play out, this is optional. I personally don't do that, but I do like to do that to show you a strategy. So it needs to multiply to be -48, but add to be positive. So the bigger number column is going to be my positive, and a difference of 2 is going to come from right there. I would need 8 positives and 6 negatives to provide me that middle term of 2v. So let's do our distribution. V squared minus 6v plus 8v minus 48. So here's our v squared, here's our 2v, here's a -48. We did it. Okay, here's that fun one again. Multiplies to be positive, adds to be negative. That means we need 2 negative binomials. These are my personal favorite. My factors, I got 136, 218, 312, 49, 66. So it has to add to be 13. I'm looking at that pair right there. Let's check it, friends. R times R is R squared minus 9R minus 4R plus 36. Check. -13R, check. 36, check. My binomial makes that trinomial. So really, guys, this was like our last lesson going from here to here, and now we're learning how to undo that. Right? That is like math and numerical flexibility. You might have heard me say stuff like deconstruct and reconstruct. It's how I do a lot of math quick in my head. And this is just that skill expanded. All right, 3 more. Multiplies to be positive, adds to be negative. That gives me a minus binomial again. Let's go. Factors of 27 or 127, 39. Adds to be 12 right there. So my binomial needs to be x minus 3 times x minus 9. To check it, x squared minus 9x minus 3x plus 27. X squared, -12x, 27. Our terms all check out. Guys, feel free to rewind this too. Like, it's on a video. You can just pause and rewind all day. All right. This one multiplies to be negative. So I need one of each here. The only way I multiply to get negative there is one of each. Factors of 32, 132, 216, not 3, 4, 8, 6, 7. Okay. So it has to have a difference of 4. So I'm looking right here. The 4 is positive, which tells me the 8 has to be the positive. So this one would matter. These have to be in those spots. They can't switch, because to get that positive 4, I need this 8 times x to happen and this -4 times x to happen. So let's check it by distributing. I'm going to distribute my x to both first. So x squared minus 4x. I'm going to distribute my 8 to both. 8x minus 32. So let's check it. Do I got an x squared? Check. 4x? Check. -32? Check. Last one, home stretch. And this is a lot like how your homework problem is going to be, all right? Just like this. So multiplies to be negative, adds to be negative. So I have to be in that one positive, one negative again. That's the only way I can multiply to get a negative third term. And so factors of 10, 110, 2, 5. That's it. The difference of 9 is going to come from 110. Since 9 is negative, my 10 has to be the negative. Otherwise, I won't get a negative middle term. So let's check. I'm going to distribute my r here. R times r is r squared. R times -10 is -10r. 1 times r is r. And 1 times -10 is -10. So I got r squared, -9r, and -10. Check. We did it, friends. I'm going to continue missing you a whole lot. Hit me with those emails. Hopefully see some of you office hours Wednesday, 3:30. I'll be there. I thought about trying a little, I don't know, wear a goofy hat or something. I don't know what I'll try to do to make things a little more interesting, get you just get there and show up and see what's up. But you don't have to stay the whole time. Just pop in and say what's up. Give me a virtual high five. I haven't seen a bunch of you, so I hope to see you there. And just keep working hard. Know I got your back.